Hello, in this second to last video where I am showing how I am integrating Jolt physics into a real engine, I will talk about how to synchronize the physics engine with a real engine. And by that I mean how we synchronize the transformation of the bodies. First of all, something that is very important to understand is that this synchronization is bidirectional, meaning that Jolt moves the bodies, and when the bodies is moved by Jolt has to propagate this transform change to Unreal Engine so that it can correctly render the object to the correct position. As you can see here, the box is falling due to the gravity. But also we want to synchronize the transform when a real engine and the actor position actually changes. We want to change the location of the object into the physics engine. And this is the reason why I say that the synchronization is bidirectional. For example, here we have a blueprint that each second resets the location of the body, does not reset the velocity of the body as you see it, because it's still inherited and it just teleports the position. So let me quickly show the blueprint here. The blueprint is extremely simple and still use the same API that we are used with Unreal Engine. Using set actor, local and rotation, and each time this function is called, the Unreal Engine resets also the Jolt position. In order to understand how this works, let's see the code. So here I have created this function onTransformUpdate, but before showing how it works, I want to show that here I am binding the onTransformUpdate to the TransformUpdate event of the scene actor component, because this scene component basically execute this event each time the transform is changed. So what we do here is very simple. We take the updated component and we extract the initial transform. Here we break the transform change in all the three components: the position, the quaternion and the scale. So why this is important is because generally in Jolt the scale is applied on the shape and not on the body. The body only works with the position and rotation. And indeed here we can see that the scale is changed using this function, this utility function that I have created inside the world, which is set scale. So this function set scale, let me show it pretty quickly, is nothing very complex, but requires some work. Essentially what we do is extracting the shape and scaling it with the new scale. Of course, this only happens if the actual scale that we are feeding is different, because in case it's the same, there is nothing to do and we just return. We store this information inside this parameter, and I explain you in a second why this is important to know. I try to do the same for set position and rotation, but this time the function is much simpler, because we, as I told you before, we can just apply the location and rotation on the body right away. And exactly like the scale function, is the passed rotation and location are exactly like the one already set on the body. There is nothing to do, so there is no reason to keep going, and we just return false. So why this is important? This is very important because in Jolt, usually when you teleport a body, the physics engine does not activate or deactivate the body nor the one that are near to the body. If you have a pile of objects and you teleport the one which is at the base of this object, all the pile of objects remain still, does not fall due to the gravity, because all the objects are still deactivated. In order to activate this body, we need to do it manually. This is something very cool that I really like in Jolt, because it gives you fine control of how you teleport things. And here, indeed, we wake all the near bodies if the scale was set or the position was set. As you know, in a real engine, you can reset the linear velocity, the angular velocity, or you can keep them when you teleport it. And this is controlled by this parameter. So at this point, what we need to discuss is the synchronization between Jolt physics and a real engine, which is basically, which usually happens for all the active bodies each frame. Let me show where I handle that. So in the past I've been showing already this function, and here we are actually processing the physics engine, the Jolt physics engine, and the function that is actually processing is this one. But there is yet another function which is synchronize world, and here we can ignore force update all, and we can go straight away to this section here that essentially takes all the active rigid bodies and only for them updates the body transform. The update is very simple in this case, because all we do is fetching the transformation from the Jolt body and we set the set transform. So at this point you may ask, if we set the word transform at this point using this function which is usually used, which is basically an Unreal Engine API, wouldn't it trigger our event? Correct. So going back on the function on transform update that I showed before, check this if condition here. Essentially, we can notice that is word synchronized. When this is set to true, this returns. And this function returns true when we execute the synchronization, thanks to this variable that we set just before calling the sync word. And in this way, we can be 100% sure that the synchronization between Jolt and Unreal does not interfere with the synchronization with Unreal to Jolt. And that's all. We are approaching the end of this series, where the next video I will show how I synchronize the event for the volumes, for the areas, and then we are done with the implementation of Jolt physics into Unreal Engine. I will start another series, but I will talk about that later. For the moment, thank you very much, and if you have any question, leave a comment or join our Discord channel, where I will be very glad to help you if I can. Thank you very much. Bye!